Today we're going to learn about Dijkstra's algorithm. Dijkstra's algorithm is used to find the shortest path from one node to all other nodes in a graph. Let's use the following graph as our example. We'll keep unvisited nodes in this vivid cyan color. Once a node is visited, we'll mark it as light blue. The first step is to pick our starting node. Let's choose node A. We'll use the table at the bottom to track the distance from A to each node. Since we're measuring distances from A, we write 0 for A and infinity for all other nodes. From A, we can reach nodes B, C, and D, so we update our table with the corresponding costs. Next, we look at the graph and choose the unvisited node with the smallest cost. In this case, it's B, so we move to B and mark it as visited. Now from B, we can reach E through the path A, B, E. We can also reach C through B with a cost of 4, which is smaller than the current cost, so we update the table accordingly. Next, we choose the unvisited node with the smallest cost, which is C. We mark C as visited. There's no update needed since there are no edges leaving C. The next smallest cost leads us to node D, so we choose D. From D, we can reach F, so we update our table with this new path. Now we choose E. From E, we can reach F with a cost of 10, so we update the table again. Finally, as the last unvisited node, we choose F. We mark F as visited with a cost of 10. Now all nodes have been visited. This gives us the shortest paths from A to all other nodes in the graph. I'll now replay this entire process as an animation. There's no voiceover, so watch carefully how the numbers change. That's it! Here's Dijkstra's time complexity. Thank you for watching.